Okay, so I'm gonna do the best today. Like I wanna show you some different things on your graphing calculator. It's hard to show you guys with the graphing calculator, trying to go like this and like pointing at buttons, and I don't wanna do that. So this is an app you can download on, I think, iPhone and Apple, okay? It's called Calculate 84. It doesn't do everything that our normal graphing calculators do, but it will do at least today's lesson, okay? So if you don't have a graphing calculator and you're at home and you need one, Calculate 84, okay? Okay, so 3.4 is talking about other types of probability and using our counting principles, okay? So first thing we looked at was permutations, which was looking at factorials. With factorials, you can do that in your calculator. If you go under math and then go to the right to probability. Okay, you should see the exclamation mark there. Okay. So if we look at this example, the Big 12 is a collegiate athletic conference with 10 schools. How many different final standings are possible? So what would your N be? How many schools are we looking at? Careful. 10. So we're gonna have 10 factorial. So in your calculator, type 10, go math, go over to probability, 4, enter. So we have 3,628,800. Wait. Okay. Then we talked about permutations of n objects r at a time. So say we only are looking at, and so the first thing we looked at was if we have 10 digits and we want to do a 4-digit code. Okay. I showed you in the video how to do it longhand, and it was kind of a pain. We had to cancel a bunch of things out. Okay. But we can also just plug it in our calculator. So what you're going to do is you're going to type in your n. So for your graphing calculator, you're going to type in the n, and then you're going to go to math, go to the right for PBR. How about? And then you're going to click on number 2 for NPR for the permutation, and then type in your R value. Okay. So if we look at this example, a psychologist shows a list of 8 activities to a subject in an experiment. How many ways can the subject pick a first, a second, and a third activity? So how many total are there? How many? 8. So that's going to be our n. How many activities are they choosing? 3. So we want to find 8, permutation 3. So plug in that in your calculator. 8, go to math, go over to probability, click number 2, and then, well, depending on your calculator. Sorry, I haven't done this on this one. There. So 336 ways. Okay. Okay, what about the third one? So 43 race cars started the 2013 Daytona 500. How many ways can the cars finish in first, second, and third place? So what's your N? How many total? 43. And how many are you trying to pick? 3. So 43, permutation 3. So mine's kind of different than yours, so I apologize. So we get 74,046 ways, which is a lot easier than having to do it all longhand. Okay. Questions with that? Okay. Okay, distinguishable permutations is the same thing, but what if something's repeated? Okay, so this example we were looking at, we had 6 of one type of house, 4 of another type of house, and 2 of another type of house. Okay, so same idea. So here we have the contractor wants to plant 6 oak trees, 9 maple trees, and 5 poplar trees along the subdivision street. The trees need to be spaced evenly, and how many distinguishable ways can they be planted? Okay, so how many total trees are there? 20. So n equals 20. And that's going to be your numerator. So 20 factorial. And then we're going to divide by each of those groupings. Okay, so the first tree, oak trees, how many were there? 6. So 6 factorial. How many maple trees? 9. And how many poplar? 5. Okay. Check to make sure your denominator all adds up to be your numerator. So 6 plus 9 plus 5 is the 20 that we have in our numerator. Always want to make sure we check that. And then you can plug this whole thing in your calculator. The key thing is you either need to put parentheses around the denominator if you're going to do it as a division problem, or if you do it as a fraction. So if you have one of the newer calculators, if you click alpha y equals, it'll bring up your fraction. Hit enter, and then you can just type it in. So alpha y equals will automatically bring up your fraction. So 20, go to your probability for the factorial. Then we have 6 factorial times 9 factorial times 5 factorial. Oh, how about not negative? And you get a very large answer. So 77,597,520 ways. Questions with plugging that into the calculator? Okay. So combinations is very similar to permutations. The difference is our order doesn't matter. Okay, permutations, you have specific positions. So first place, second place, third place. President, vice president, secretary. Okay, there's positions that they have to go in. Combination, you're just creating a group of 3 people. There's no specific placement or order of them. You're picking 3 people to win the race. You're not picking the first, the second, and the third. Okay, so that's the difference between permutation and combination, is all about that order. So if we look at this example, the manager in an accounting department wants to form a 3-person advisory committee from the 20 employees in the department. And how many ways can the manager form this committee? So there's no specific positions, it's just a group of 3 people. So that's how we know it's a combination. So what is our N? How many total people are there? 20. How many are we choosing? 3. So 20 combination 3, you're going to use the same rules that you did to find permutation, but instead of going to number 2, I think you go to number 3. Okay. So you're going to go to math, probability, and choose number 3. And we have 1,140 ways. questions? Okay. So now, so an application, a student advisory board consists of 17 members. 3 members serve as the board's chair, secretary, and webmaster. Each member is equally likely to serve in any of the 3 positions. What is the probability of selecting at random the 3 members who currently hold the 3 positions? So what's our N? How many total people are there? 17. How many people are we looking at? What's our committee consist of? 3. So that's our R. Now, is it a permutation or a combination? Combination? Are there specific positions? Serve as the board's chair, secretary, and webmaster. Okay, so they're each going to have a specific position, which means it becomes permutation. Okay. That's the reason why it's going to be a permutation. It's not just a group of any 3 people. They have specific positions that they're filling. Does that make sense, the difference? Okay. So we have 17, permutation 3. So how many total options do we have?
$4,080.
4,080. So that's the number of total ways. So what's the probability of choosing the current? How many times are you going to be correct? Take a guess. There's one way to pick the correct group. So 1 over 4,080, which is going to equal 0.0002. Okay. All right. A student advisory board consists of 20 members. 2 members serve as the board's chair and secretary. Each member is equally likely to serve in either of the positions. What is the probability of selecting at random the 2 members who currently hold the 2 positions? So what's your N? 20. What's the R? 2. Are we doing combination or permutation? Permutation, because there's positions. So 20 permutation 2 equals what? 380. So the probability of selecting the correct one would be what? 1 over 380, which is approximately 0.003. Okay, looking at distinguishable probability. You have 11 letters consisting of 1 M, 4 I's, 4 S's, and 2 P's. If the letters are randomly arranged in any order, what is the probability that the arrangement spells the word Mississippi? So we're doing distinguishable permutation. So how many total letters are there? 11. So we're going to have 11 factorial divided by, and then do each of your groupings. So we have 1M So 1 factorial. And then what else are we going to have? 4 factorial, 4 factorial, and 2 factorial. So plug that in your calculator. And what do you get for the number of ways? Okay, 34,650. Ooh, sorry. Okay, so the probability that it says Mississippi there's going to be one possible way that it can say Mississippi out of that 34,650, which is approximately 0. And then 4 zeros, 3. Okay, so that's kind of like your basic probability with your counting principles, okay? We want to go a step further with it. So find the probability of picking 5 diamonds from a standard deck of playing cards. So we need to start off with finding how many times can you pick 5 diamonds? Okay. So how many total diamonds are there? 13. So n equals 13. Of those 13 diamonds, how many are we wanting to pick? 5. Do we care about the position in which card we pick? No. So is that going to be a permutation or a combination? What'd you say? Combination, because we don't care about the position. That's the hard part. Remember P and P, position, permutation. So we're going to find 13 combination 5. Okay, so find that. What do you get? 1,287. Now we just need to find 5 cards. So that way we can find the total. So how many total cards are there? 52. Of those 52 cards, how many are we choosing? 5. Do we care about the order in which we pick them? No. So is it permutation or combination? Combination. So 52, combination 5. Plug that in. Tell me what you get. About 2,598,960. So then the probability of choosing 5 diamonds is going to be 1,287 divided by the 2,598,960. So divide that and let's go to 4 decimal places. What do we get? 0.0005. Okay, and let's do the last one. A jury consists of 5 men and 7 women. 3 jury members are selected at random for an interview. Find the probability that all 3 were men. So the probability that we choose 3 men. Do we care about the position in which, or the order in which we choose them? No. So does that mean we're doing permutation or combination? Combination. So we're going to break this apart. We're going to look at men, women, and total. So how many men were there to choose from? 5. So 5 men. Of those 5 men, how many do we want to pick? 3. Times. How many women were there? 7. Of those 7 women, how many do we want to pick? 0. And then total, how many total people were there? 12. Combination, how many total were we picking? 3. Here's something to notice. Your front numbers should always add up to be the same. 5 plus 7 is 12. And then looking at your back numbers, 3 plus 0 is 3. If they don't add up, you miss something. Okay, that's what makes those kind of tricky. So now plug that in your calculator. And what do you get? Make sure if you're going to type it in as division, make sure you put parentheses around your numerator. And let's just do 3 decimal places. Anyone got a guess? Close. Oh wait, actually, I might be right. I think I went to 4 decimal places last year. So yeah, 4.5. 0.045. Questions with that? Okay, you guys are good.